Hello and welcome back to the Genomics Bootcamp. This video is an introductory to a series where we talk about R and R scripting. This will be a series of short videos where I explain bits and pieces of R and R commands that are very useful for the things that are doing on the channel. Actually, this idea came when I was reviewing my R scripts, and I realized that about 80% of the time I tend to use the same relatively small number of R commands and R tools. So it was then when I realized that, well, if you know this relatively small part of R, you are good to go for most of the stuff that you want to do with genomics, or at least the most of the stuff we tend to do on this channel. This is the first video, so we start with the most important R tool of all. And this is, of course, the hashtag or the comment lines. That's right. One of the most important habits you can learn is to comment your files and comment your scripts appropriately. And for this, we use the hashtag sign. Whatever you write after the hashtag sign, it will be interpreted as a comment line. So it will be actually not interpreted and not run by the program, but you will still obtain the information, you as the observer or the person who is using the script. This is extremely important because, well, the scripts are not written for the computers, but they are written for people. So people need to understand what's going on in the script so they can run it or, if necessary, modify it. And when it comes to understanding the script, this includes your future self as well, because I can assure you, you write a script today, you will sort of know what's going on in it tomorrow or after that, but I am quite certain you will have a hard time to figure it out 2 weeks, 2 months, or maybe a year later. And for this, the comment lines are really, really necessary. The most common use of a comment lines could be as indicated here. So it could be standalone for some kind of a title, or explaining pieces of the code as indicated here below. Also, the hashtag could be used within the line. So everything after the hashtag is a comment. So the first part of the line could be used for the code itself. When you write your comment lines, make sure that the information that it conveys is really useful for the reader. In case of a longer script, the hashtag signs also could be used as a neat divider to visually distinguish the parts of the script. For example, like this. In RStudio, there is one other functionality here. So if you click on this small button here, so the parts of or the lines between these long lines are temporarily hidden. If you want them back, you just click on this small arrow again. If you want, you can also create neat boxes like this to further visually distinguish the parts of the script. Here, the temporary hiding of the lines also works, so you can neatly hide the parts of the script that you are not interested in currently. If you do not want to delete some lines or even the whole sections of the script, you can just comment them out, so when you rerun the scripts, they are not executed. Of course, if you want to comment out many lines of the text, these might become cumbersome. So there is a very neat shortcut for this in RStudio. So you just highlight the rows that you want to comment out, you press Ctrl-Shift-C, and it's commented out in its entirety. If you want this section back, the same thing needs to be done. So basically, you highlight what you want to uncomment, Ctrl-Shift-C, and you have it back in its initial form. So I repeat again, using the comment lines is the single most important habit that you need to start doing when writing any kind of script. And this is not just for R, but really, really any kind of script that you write on a computer. The center of this video is here in line 5, a variation of a remove command, which actually clears the whole workspace. I use this line in all of my scripts, and I find it very useful, and also I will demonstrate you in this video why is it useful in my view. So it's not extremely necessary, but it's nice to check the help files for these commands. So if you are here on the command itself and press F1, the help file comes up. So here you can see that this is basically the variation or the shortcut for the remove command, which removes certain objects from the environment. And if you scroll to the very bottom of this, then here is the most interesting lines of them all, at least for this help file, which says, remove almost everything in the working environment. You will get no warning, so don't do this unless you are really sure. And here is the line that I use in all of my scripts, despite the warning which is shown here. Before I get to my particular example, let me demonstrate you how the line works by default. So we run this dummy script here, and you see that there is a bunch of, variables in the environment. And just by running this single line, everything vanishes. So the environment is empty. And now to my example. So I use this line at the beginning of each script because I want exactly this to happen. So the environment is clear all the time when I start to run the script. This is because of a type of an errors that can occur during the development of the script, which are quite hard to track down, especially if the script stretches for hundreds of lines, which sometimes can happen with the large analysis. So let me demonstrate. We comment out this line here, so it doesn't remove everything for us. And then we run the rest of the script. So we have our two variables here, and we have our final result. But then we decide to change this small equation here, and we want to add not the second number, but the third number to the final result. So we change this. But because things happen and mistakes happen all the time, we make a typo. Because R is case sensitive, so this variable doesn't exist in our environment, so there will be an error here. So technically, the final result should not appear at all. But when we run it again, although there is an error message here, we still get the final result as before. Again, this is a very short script, so this here is quite obvious, but imagine script that is, let's say, 50 or 100 lines long, and this small error message is buried somewhere in the middle. This is quite a typical occurrence when you change something in the script and you keep getting the same result, although you expect a different one. So this type of error might be causing the problem. But again, it's quite hard to track down because you have a final result and you have a final figure, and you are not ending up with a huge error message at the end. Another typical example is when you work on a script full day, perhaps, and then you close down R, and then you return to it next day, and you run exactly the same script, but it doesn't work anymore. So it was working yesterday, but it's not working today. And then you are scratching your head, what happened? Again, a similar error could be the problem. And you can avoid all this just by including this line here. So it wipes the entire workspace and the entire environment at each run. So when we run this again, we have suddenly more error messages, and more importantly, the final result does not appear. That's because one of the crucial numbers is not defined correctly. Previously, everything was running because the old result or the old number was still in the working environment, but now it's not because we wipe the environment all the time. And then we are forced to look for our error. And finally, when we find it, we rerun the whole thing again. And then we are getting the new result, which is now the expected one. So to sum up, clearing the workspace at the beginning of each run, especially when you are developing some kind of a script or analysis. So this I find extremely useful. Today we will be talking about joining multiple strings, so series of letters together using the str_c function. If you don't know any function, the first thing to do is always look at its help file. So you can do this the most easily by clicking on it and then pressing F1. So from here, you can learn that it is to join multiple strings into a single string, and also there is a short description and a description of use. It is a part of the string_r package, which is included in the tidyverse. So that's why I have the tidyverse loaded here. And of course, it is not carryable, but variable to change. Anyway, so I defined here a variable and then a short sentence which says, hi, my name is, and then includes the name which is defined. So when we run this part, the outcome is, hi, my name is Gabor. So here you can see a little mistake. So namely that there is no space between the S and the G here. That is because the default separator variable as defined here, if we don't define anything, is basically nothing. So there is no separator defined. In this particular case, there is multiple ways to fix this, either by including a space here or defining the separator variable at the end of this line. So we say sep equals and a space. And we rerun the same, and then now it's displayed correctly. Now, of course, if we change this and we say Bill, then we rerun the whole thing, and now it says, hi, my name is Bill. If we want to extend this line, we can do so by adding more parts of text between double quotation marks or more variables. These should be separated by commas. So if we add something here and we rerun, then we see that this is correctly displayed here. This command, the str_c, is very similar to the paste command or the paste 0, or not command, but function of base R. But because personally I prefer I'm trying to use tidyverse more, so I prefer the strc, but the paste or the paste 0 are equivalent commands doing basically the same thing. Now you can do quite a number of quite fancy things with this strc, as you will learn here in its description. But frankly, what I intend to use it for is just pasting together simple text. You might recall parts of the scripts similar to these from my previous scripts, when I use this strc command mostly to generate blink lines that are then being run with the system command. Here, notice that the setup of the lines is really the same as before. So there are multiple occurrences of text between double quotation mark, and then there is a variable and the text variable, and again a text. Multiple variables or pieces of text also can follow each other, but the most important is to divide them by a comma. Here I take care of the spacing within the quotation marks, so I don't specify the separation or separator values. So I accept the default separator that is shown here. So of course, if we run this, then we have the long blink line. So when we change our mind and we want some different values in the runs, so we don't need to search for them in the commands, but just changing the variables, rerunning them, actually then produces the line that we want. Again, this is just an example use, but there are many occasions when pasting or joining together strings is extremely helpful when analyzing genomic data. So this definitely should be in your inventory when it comes to writing script files in general. In this video, we will talk about two R commands, both related to the packages. Now, when you install R, you get the so-called base package. It already contains a lot of stuff, but R can do just so much more. And this is because the many contributed packages that you first need to install and then load, and then you can use them for various kinds of analysis. The installation of packages is very easy. You just need to specify the install.packages command and then put the name of the package you want to install between double quotation marks. If you do such an installation for the very first time, you might get a pop-up window that asks you to select a mirror. This is just the site or the R server where the data is downloaded from. Technically, it doesn't matter which one you click, but it makes the most sense that you click the place or the server which is geographically the closest to your current location. And then you can proceed to run the line. So also the easiest is to be on the line. So click on the line and press run, and then the installation proceeds. Depending on the number and size of the R packages and your internet speed, it can take a various amount of time, but R packages are generally very small, a few hundred kilobytes or a few megabytes. Also, in some cases, more packages are downloaded if the package which you are installing has some other packages that it depends upon, but these dependent packages are not yet installed on your computer. So R recognizes this and installs everything that you need. Now I installed this package Palmer penguins for a specific reason, because we will be using the data from it and the data set which is called penguins. When I try to run this, it will come back with an error message that there is no object penguins in the work environment. That is because installing packages is not enough, but you need to also load them. And you load them with the library command and then specifying the name of the package. If we load the packages now and rerun the very same line, now it executes, and now we see that it recognizes the data set that we will be working with. Of course, you need to load all the packages that you are planning to be using so that you don't need to return to this part all the time. This short video is about one of the most beautiful features of R and R tidyverse, which is the and then command or the pipe command. Maybe I'm getting a bit too personal here, but I fell in love with R tidyverse, and the two main reasons why this was or why this happened. First one was the pipe commands. The other one is the clarity of the commands and the function names. We will get to those ones a bit later, but today or in this video, we will discuss the pipe commands. And the pipe command itself is a series of characters, the percentage mark higher than percentage mark. So these three characters here and here. So this is the pipe and should appear together all the time. What it does is that it takes the input from its left side and passes it on to its right side, or in this case, to the next line. This is extremely beneficial because you don't need to create additional data sets, temporary data sets for each and every step, but you can basically just design the workflow and look up the end product of it. Here I put together a very short analysis where we start with the penguins data set from the Palmer penguins package. So we need to actually load the Palmer penguins data set, and also because the pipes themselves are the part of the tidyverse package, so we also need to load the tidyverse. So the library tidyverse and library Palmer penguins needs to be run before all this will work. But then what we do is we take the penguins data set and then we filter some rows. In this case, we just filter the Gen2 penguins, and then we do a basic statistical summary or a basic statistics of this data set. After we run this part, we see that there is the end product, what we wanted. There are no additional or temporary data sets created, and we still end up with the result we want. To me, coming from the base R background and also maybe a little bit of bad habit of creating all too many temporary files, this change and this pipe command is really, really beautiful. So if you use tidyverse, get used to it, use it, it is really worth it. This video is about the subsetting of datasets, namely if you need just some columns from your initial dataset, you can easily achieve this with the select command. To run this small script, you will need both tidyverse and Palmer penguins loaded. But let me show you what I mean by selecting on the columns. So if we run just the Palmer penguins command just straight away, so just to see that there is 8 columns actually in this data set. Now let's say that for some reason we only need the species, the island, and the body mass columns. We can easily achieve this by piping everything together and starting from the Palmer penguins or the penguins dataset, and then, so this is the pipe command, the and then command, we select only these 3 columns. You do not need to use any quotation mark, single or double. Tidyverse will recognize that these are actually the names of the columns in the data and will do the correct operation. So after we run this part, we indeed see that we have just the 3 required columns in our output. If you call up the help file of the select function, which you can the most easily do by clicking on it and pressing F1, so you will get here and you see that there is a lot more to learn about the select command. We will perhaps get to these as well, but when it comes to genomic analysis or for my personal use, really most of the time what I need is just select those few columns that I specify. Well, there is also an additional feature of the select command, and namely that it also sorts the columns according to your specification. So right now there is species, island, and body mass, but look what happens if I put the body mass into the first place, for example. So we need to, of course, divide them by a comma, and the last comma needs to be deleted. But when I rerun this, then we see that indeed the body mass is in the first place in the new dataset. This is often very handy because you don't need to implement yet another step to reorder the columns if a specific order of the columns is necessary for your follow-up analysis. Of course, if we don't want to have the data just on the screen, but we want to save it, we can do so by specifying a variable. I here specify in a very creative way a variable named TMP, which of course stands for temporary, and then hit Alt and the dash, which produces this neat arrow. And when we rerun this, now we have this little temporary data set in our global environment. Now it is also clickable, so if we want to check it out, we can do so. And we could be happy that we learned this very, very useful command that is selecting and subsetting the specific columns that we need. Perhaps a very short note at the very end. So this arrow structure, so this lower than and dash was created by the shortcut Alt and the dash, or of course you can type it out as well, but also the equal sign is equivalent to it. But as I recon, this arrow is used more often. So I will advise you also just to learn that and use this arrow instead of the equal sign when you want to create new variables. This time it will be about filtering rows according to specific conditions. As before, we will need the tidyverse and Palmer penguins packages loaded. The main star of this video is the filter function, which basically allows us to produce a subset of rows according to our wishes. As always, perhaps the first thing to do is to click on the name of the function and press F1. This brings up the help file, which is quite an interesting read. It is quite detailed and you get quite a bit of information from it. I would drive your attention perhaps to 2 parts of it. The first one is this useful filter functions. So you could actually check out these and well, get some impression what are the possibilities with the filter function. And the second one is a very extensive examples section. This actually gives very handy examples. So if at any point you would not be sure how the thing is working, then you can call this one up and try out some of these examples, and then you would see right away. Here I prepared also a few examples for you with our favorite penguins dataset, and the first one is basically just filtering out all the penguins that have a body weight more than 3 kilograms or 3,000 grams. We can do this very easily by calling on the penguins dataset and then filtering things out that have the body mass of more than 3,000. And this body mass G here is actually the name of the column we are filtering on. So again, we do not need any quotation mark or anything because a tidyverse package will recognize that this is a column name and act accordingly. So when we run this, we see our first file here with 331 observations and 8 variables. So basically, this many animals or this many penguins fulfill the condition, that is, they are weight more than 3 kilograms. Filtering according to numeric values is not the only possibility. We can also use expressions or character strings to get out what we want. In this case, we try to filter out the Adelie species of penguins from the joint dataset. We run this part with the second, for the second run, and we run into a problem. This problem being that our second dataset does not have any observations, so does not have any rows. Now, because we wanted to filter according to the species name, so we had to put it between double quotation marks, so that was fine. But the other stuff that we did not abide to was the capitalization or the correct use of capital and lowercase letters. Here I would remind you that R is case sensitive, so you have to be careful how you are typing things down. Also, R tends to execute commands if such an execution is possible without huge error messages. In this case, it tried to search for the Adelie species with the lowercase a, did not find any, so basically it printed out an empty dataset. But of course, what we wanted is the Adelie penguins with the capital A. When we rerun this, we see that we have indeed 152 of them. It is also possible to use multiple conditions. So for example, if we want to filter out penguins that have more than 3 kilograms and they are from the Adelie species, of course, we can use this extra symbol here. So basically, this takes both conditions into account simultaneously. And we see our third dataset, which consists of indeed the Adelie species weighing more than 3 kilograms. Today we will talk about the mutate function, which is to create, modify, and or delete some columns. Of course, the first thing, as always, to call up the help file. Well, I have it already here, but if you don't, you just click on it and press F1, or basically just write mutate into the search box here, after you have loaded the tidyverse package, because this mutate is also the part of the tidyverse package. Also, we load Palmer penguins because we will use it for the demonstration. Anyway, so the description of the mutate function, or the help file for it, is quite detailed, I must say. So you can read a lot about it and how to use it in a quite sophisticated way. Also, here I would point out the useful mutate functions, so you can actually combine the mutate function with these to achieve even more and even more grandiose results. Also, there are some very neat examples, so you can check these ones out and also perhaps get some ideas how to use mutate or the mutate function even better. Here I put out just a very small example, and frankly, this is the way how I use it most of the time. So if you know its basic use, you're quite okay already. And of course, then you can move on and improve your knowledge based on the help file or other very useful materials that are online. So what is the purpose of our small example here? So we have the penguins data set, which, well, we know it consists of, well, 344 animals, but more importantly, 8 columns. And one of these columns is the body mass in grams. Let's say for some reason we need another column that gives us the weight of each penguin, but in kilograms. So we can use this very easily by using the mutate function. So we start with the penguins dataset and then we use the mutate. And here within the brackets, we have this small expression. On the left side of this equal sign is the new name. So this will be the name of the new column. And then this will be equal to the, well, in this case, the body mass in grams divided by 1000. After running this, we notice that our new data set has 9 variables. And if we click on it just to check out the contents, we see our new column with the name that we specified and with the new values. Again, here I would mention that when you're using column names within the function, within the mutate function, you do not need to specify it with quotation marks or anything like that, because tidyverse recognizes that, well, this one is an existing column name and the other one is the new column name that we are trying to give. So you just can write these names like this in a very straightforward way. Today I want to talk about perhaps not so well known R function called ggplot, which is of course just a joke because the ggplot from the package ggplot2 is one of the most well known and most iconic parts of the tidyverse R package. It is a very, very versatile function with a large number of possibilities and options, which would perhaps deserve a video series on its own. But for today, I just want to mention it in a very brief form and then provide short demonstration of how it works. So the ggplot is basically to do many types of visualizations, and also it is based on a layered system of graphics. And what it means, what these layers mean, I will show in a minute. The logic is the same as for the other parts of the tidyverse. So we have our statements here or various lines, and we add them up like puzzle pieces. So for example, if we run this and let's say, I want to comment on the themes a bit later, so I just skip this for now. But let's say we run this ggplot, which is already prepared from the penguins part. So we have this very neatly looking graph here where we basically we can do whatever we want. And here we plot the flipper length millimeters and the bill length millimeters for these penguins for all the 3 species. As you see here, there are multiple things happening. So basically all the species are colored in a different way. Also, they have a different shapes, and also there are regression lines running through them. And all this with this very brief code or very brief script, which is basically just saying that what are our X and Y variables, what we want the color and shape to be looking like. So it's according to the species. We want them a little bit larger, and we also want these regression lines running through them. What I mentioned with the layered graphics, so basically these are just very literally different layers of the graphs and graphics that are put upon each other. So basically, if I comment out, for example, these 2 lines, or basically this is just one line dealing with the regression lines, and I just rerun the same thing. So basically I get very same graph without the layer of the regression lines. And also if I decide to add some of the many other options and possibilities of the ggplot, it actually will show up in a very same way, a similar way on my graphs. As I mentioned, it's quite similar, or the logic is quite similar to the tidyverse itself. So basically we have different statements here, and these statements or lines are connected this time not with this percentage mark higher than and percentage mark, which is then pronounced as the and then connector, but in this case it just connected, these lines are connected with a plus sign. So again, if I decide that I want this layer back, just uncomment, rerun, and I have it back again. What I like on this is that it's very straightforward and also very clear what each of the functions do. And now for the themes that I removed from here before. So this is kind of a bonus option if you want to change the looks of these graphs just in a very quick way, and you have basically your favorites that how these graphs should look like, and you, for example, you don't like this grayish background, so you have different themes you could use and change your graphs and graphics in a different way. So if you run, so this is actually my favorite, the black and white theme. So you see that the overall picture remains, but the overall look and feel of the graphs is quite different. As for these themes, also for the plotting options, there are loads and lots of possibilities. So certainly the ggplot is one of the options or one of the R functions that not just deserves your attention, but one of the R functions that are extremely crucial to know about and extremely crucial that you can handle well if you want to do just about anything in R. This one is kind of a follow-up to the last time when we discussed the ggplot. Of course, if you make some nice graphs, more often than not, you want to use them somewhere else, so you need them in the file format of your choosing. And to do this, there is a very simple and very neat solution called ggsave. So we follow up from the last time. So we have the same graph as before, and we want to save it to the hard disk. So we don't have to do anything else, just to write ggsave and the name of the file that we want to have our graph saved into. And it is simple like this. So in this case, I write penguins build flipper length PNG, I run it, and it is already saved on my hard disk. And looks like this. If you look at the function arguments, also you will see the files or file extensions that ggsave is able to save graphs into. So for example, if you want a PDF or want to save the same thing in the PDF, you don't need to do anything else, just to actually rewrite the file name to penguinsbuildflipperlength.pdf, run the whole thing, or actually run the ggsave line again, and now you have it in PDF form. Technically, there is this device here, which is a separate function argument, but from my experience, if you just write the name, what you want, and with the file extension .pdf, it's already working. Here I want to underline that is saving always the last graph that you made in R. So, so if you want to make like a bunch of graphs and you want to save all of them, after each one you write the ggsave command, and then it saves all the graphs for you. Well, sometimes you might not be entirely happy with the format of the picture, and it is very easy to change. So you just define the width and the height of the picture and the unit you want to have it in, so you can have it in inches, centimeters, millimeters, or pixels. And well, basically you just specify this and then rerun the whole thing, or again, not the whole thing, but just the ggsave line, and it creates a picture of the desired size. Also, just want to note, I went back to the PNG here for this process. one more thing I like on this very much, that, sometimes the journals or various publications want a picture of a certain resolution. So it should be certain number of dots per inch, or in other words, a certain DPI. This is also very easy to arrange. So basically, you just use the dpi function argument here, well, which is called dpi, and you just specify what your dpi should be. And again, with this, by rerunning, you just get the work done. So I like very much this ggsave. It's a very convenient thing to use, really a game changer, at least for me, and a huge quality of life improvement when it comes to saving my graphs as pictures or PDFs on my hard disk. So definitely a warm recommendation from my side. So you also try it out and use it. This time we will be talking about dropping lines from the text that contain missing values. And it is done very conveniently with the R option, drop NA. Again, we will continue with the penguins dataset, and here you see that sometimes there is an NA, capital NA, in the dataset that is a shortcut for non-available or missing. There are situations when these missing values are not a problem. For example, when we run the ggplot figure from this dataset, then you could see that, well, two warning lines, but basically the ggplot removed these missing values by itself. Sometimes, however, you want your dataset set up in a way that it does not contain any missing values, and you can do that very easily with the drop NA command. So basically, you just say drop _NA and run, and we have our new dataset here, which you see that there doesn't contain any missing values anymore. Depending on the situation, you might want to remove missing values just from some columns. So you can do that very easily just by considering the column name. So again, back with the original penguins file, and let's say we want to remove just the NAs or the missing values from the bill length in millimeters column. So we just specify it here in the drop NA between the brackets, run it, and you see in the bill length NA doesn't contain any missing values. Here are some missing values in the other columns, but these are not of interest for us right now. Also, if you want to remove missing values from multiple columns, you just basically specify these column names in an R dataset, as I did it here with the measures vector. So basically, this is just the names of the columns. I run this, and then in a drop NA, I take or write any of the measures contain NA that should be removed. So when I run that, basically it removes all of the NAs from those columns. So pretty straightforward and useful too on many occasions. This time we will be talking about a number of commands that are kind of similar, and this is the join command and its variations. Basically, you use this if you want to merge two datasets. Also, for this example, we will use the penguins dataset. Now, what join needs, or the join commands need, is a column that has a unique ID for each individual. This is actually present also for the penguins dataset in the penguins raw dataset, but that has a lot of other issues as well, with which I don't want to deal with now in this simple example video. So I decided to create a unique ID for myself. So this is this first part when we create a penguins GBC dataset that is, of course, standing for Penguins Genomics Bootcamp, where we add an individual ID, where we say penguin number and then with the row number. So basically, it will be a column of IDs with penguin number 1, penguin number 2, 3, and so on. So when we run this, we can actually click on it on the right side here. So you see there is an individual ID column, penguin number 1, 2, and so on, up to about the 300 something that is in this dataset. In my experience, we don't need 344 observations to demonstrate a simple thing. So that's why I created two subsets. So penguins subset 1 here is the penguins GBC, but only the observations or the penguins 1 to 10, and then 21 and 22, just to spice up things a little bit. In penguins subset 2, so there are penguins from 6 to 15, and then 31 and 32. So you could see that basically the penguins 6 to 10 are overlapping between the two subsets. And now let's go for the join types, or basically the merging of these two subsets based on individual ID. So there are 4 join types that are described briefly in the help files. So the inner join that includes all rows from subset X and subset Y. So basically the individuals that are in both subsets. So let's try that out. So you see here that indeed the penguins that were in both data sets, namely penguin number 6 to penguin number 10, are in this resulting data set created by inner join. Now, sometimes there is a requirement that for some reason you want to keep all the rows from either of the data sets. That's when you use left join and right join. So, well, it does something similar compared to inner join, but the left join here includes all rows from X. So basically all rows which are on the left side of this function argument, or basically the first function argument in the left join function. So if we run this, I will show you what I mean. So basically here there is everything from penguin subset 1, and then the overlaps with penguin subset 2, which is basically the 6 to 10. So we have this segment of the data. If you want to keep everything from the second subset, so the one that is on the right side of this function argument, then you use the right join. So that basically includes all rows from the dataset Y. So after running it, so we have the penguins 6 to 15, and also the ones 31, 32, because these were also in the dataset penguin subset 2. If you want to ensure that all rows from both datasets or both subsets are in the merged or joined dataset, then you use the full join. So here you see all the penguins from 1 to 15, but also 21, 22, and 31, 32. Actually, the help file for these functions are one of the better described ones. So you find also here a ton of examples and possibilities. For example, if you want to use a certain suffix, or if you have the missing values in the two data sets coded in a different way. So these NA matches NA and never, for example, in this particular case. So there is a possibility to match also the NA values. Or if you scroll to the very end, there are also some additional examples. In my example, I divided the same data set into 2 parts, but of course, in reality, you might face different circumstances. And one of these circumstances could be that the ID column, so the one that is crucial for matching for the 2 data sets, is called in a different way. And this could be very easily solved by the by statement here. So this is something that you want to check out if your column names in the 2 subsets are different. So you also can specify them in the join statement and deal with them in a very quick and efficient way. So when in doubt, I really recommend to run these examples and see what they do. This will be a short video how to change column names in R, especially with the dplyr R package in tidyverse. From time to time, you either not happy with a certain column name or for some reason you are required to change it. And to solve this issue, by far the most straightforward and quick solution is to use the rename function. It has also a small help file where you can find out that you have to use the syntax new name. So in this case, the new column name equal the old column name. So what it means. So when we run the penguins data set, we see that there is a bunch of columns here. And there is, for example, this year column. And for some reason, you want to rename it, for example, to be more precise and say that this was the year of the study. So for this occasion, we create a new data set that is penguins GBC, standing, of course, for the penguins Genomics Bootcamp. And we say the study year. So the new column name is equal the year, which is the old column name. So this is used within the rename R function here. So what will happen is that everything will remain the same, and this year column name will be changed to the one that we specified. So it is a really quick process. If we click on this, we see that everything is totally the same. And here we indeed have the study year column name. Of course, you don't need to do columns one by one, and you can do more columns at once. So if we want to change more columns, study year to year, and penguin species needs to be the new column name, which was previously just called species. We can do it in one line. So we run, we click, and we see that basically the two columns are indeed changed. This time we will be discussing a really neat and really useful, I would call it the solution, where you could create various subsets based on your specific conditions. The function we will be using is the case when function, case_when. Again, it has some description in the help, and you can read here that this is a function that allows you to vectorize multiple if-else statements. So basically what we want to do is check for certain categories or certain conditions, and if these conditions are fulfilled, then we want to call this category in some way. This is super useful if you have some observations, for example, and you want to put them into several categories. Here in this toy example, we will be using the penguins dataset and the combinations of the species and the island where they come from or where they were studied. Also making this quite short, so basically we have just about 3 categories. But of course, you can have any number of categories as you wish. So this is somewhat more complicated, but I will walk you through and you will see that it's not that difficult. So basically what we want to do is create a new column, and you know already that the new column is created by using the mutate statement, and this column will be called study set. Now here comes the good part. So we use case when. So the case when is just another way to tell that certain conditions will follow. So in case when the species is Adderley and the island is Biscoe, then we want the study set be called Adderleys from Biscoe. So in other words, we check on the species, which is, this is one column in the penguins dataset, and the island is another column in the dataset. So if there is Adderleys and the island is Biscoe, we call the new column Adderleys from this Biscoe. Well, not Biscoe, but almost. Anyway, so then there is another possibility. If the species is Adderley and the island is Dream, And then we call this new study set dream Adelis. Of course, this is all, both of these are just my examples. And of course, you can go on as long as you wish with the combinations. But at the end, you arrive to a situation that you specified everything you wanted. And for example, these two categories, the only two that I am interested in. So then you can say that the rest of them, which doesn't fit into these conditions, then should be called, well, the category should be called not interested. And this is, say, is true, is tilde sign. So this is just to make sure this is not a equal sign, but this tilde sign, and not interested is, well, again, just a category name I came up with. So let's see how this works. So again, it ran and it's created a new data set. And here we have a new column as we specified. So here, this is Adeli Torgersen. So this was not among the combinations. So this is not interested. And for example, here there is Adeli and Bisco. So Adeli is from Bisco. And then Adeli Dream is Dream Adelis. And then the rest according to our specifications. Now there are a few other things to note here. So here you see that I use two equal signs, so the equal. So this is to specify that the species must have exactly this expression when we are talking about text, or if we would be using numerical values, which is of course also possible, then exactly that numerical value. Of course, if you use columns which have numbers in them, then of course you can use higher than, lower than, or higher equal or lower equal signs as well. The other thing to note is this and sign here. So this is, well, just really says that this condition and this condition has to be true. There is another possibility, the or sign. So this is with this vertical bar here. It's not an I, it's not a lowercase l, but this is a separate sign, which is called vertical bar, which stands for or. So if you change this, then it would say that the first expression or the second expression should be true in order to assign this category name. Let me demonstrate what I mean. So I changed this second and to or. So basically now what it says that if the species is Adeli or the island is Dream, then it will be assigned Dream Adelis, which is, well, of course, now it will be incorrect, but you will see actually the change in the categorization. So if I rerun this and check again, you see before that, it was also, well, not interested here. So this kind of default categorization. But now, because the species or one of the conditions is true, then also these individuals are categorized among Dream Adelis because they are, Adeli is true here. The same way, other penguins from the Dream Island, which are a bit down somewhere, for example, here, so you see that is a different species of penguins, but they are from the Dream Island, so they are also categorized under this heading. And that is because we use this or sign here. So this is something to take care about and set up your conditions in a way that you want them. So back to the correct setup, just to be on the safe side here. So once again, the structure, how to use these conditions. So you create a new column with mutate, you name it however you want, and then you use the case when. Then you give your conditions based on the column name. So the column name should be equal to, lower than, or higher than some values that you specify. You might combine these values. So you can combine values from different columns. Then you use the tilde, and then you give the new name to your category. So you can have here any number of lines you want. They are divided by commas at the end of the line. So you can have more lines, and then at the end, whatever doesn't fit, you say true. So this must be actually capital letters, or capital letters through tilde, and the name for the category that doesn't fit to any of the previous conditions. And yeah, basically that's it. It is a very useful solution that I use fairly often. This time we will be talking briefly about reading files from your hard disk and writing out text files to your hard disk. Until now in this series, we were dealing with the Palmer penguins dataset, which is actually already located in R. But many times what you want to do is to read in some external dataset from your hard disk to R, where you want to do something with it and perhaps visualize it, perhaps modify it, or, well, there is just a million things you might want to do with datasets. For this, you definitely need to read it in, and then many times also you want to write it out. There are many possibilities to read in and write files depending on the file at hand. So if it is a space delimited file, tab delimited, comma delimited, Excel, or any other type of file that has a certain specific feature that you need to take into account. If you want to know all the possibilities, so what you can do is go into, well, the RStudio and start to type, for example, read. And then it comes out basically all the options and possibilities. Generally, the read with the dot there, these are from base R, and then with the read and the underscore, these are from tidyverse. So you see that there is lots and lots of possibilities for this. I will use or demonstrate just one, and this is again my personal favorite, and this is the read underscore delim, so read delimiter. So this is generally a more universal one, because then you can, or actually have to, specify the delimiter yourself. And the delimiter itself is what is located between the two columns in the text file. So of course, if you want to read in something, you need some kind of a data set. And for this particular example, I used the dataset from the Tidy Tuesday exercise from 2nd of August, 2022. So this is how the dataset looks like. It is actually a dataset from telemetry records from the Oregon spotted frog by Michael J. Adams. It has a number of columns, for example, the site, the subsite, the habitat type, and so on. So there are the column names in the row 3 here, and then there are the certain values for each of the rows. And then the two columns, which is the most important part here, they are divided or delimited by a comma here. So what is the most important here, that the actual data set starts from, well, line 3 here. The line 3 is the so-called header. And then afterwards, there are the observations. And as mentioned, there is a comma between the two columns. Coming back to R, we take this one into consideration when we are reading in our data. So I chose to read this one in with the read underscore delim. So I give the full path here, but of course, if this particular file is in your working directory, then you don't need the full path, just enough if you have the actual file name. And this is, well, here I would underline, this is the entire file name. So you also need the file extension itself. Well, this is the part that, well, some people sometimes forget. So this is why I underline it. So you need the full file name in the quotation marks. So our delimiter, as mentioned before, is a simple comma. And because our actual data is starting from line 3, That means that we want to skip the first two rows. So that is why we have this skip equal to here. So actually it starts to read in from line 3. If we go back briefly to the description of the read delim, well, R function, here we can find that the column names are by default considered. So the column names are equal true. So then we don't need to specify that the third row is actually the column names, but it takes it automatically. By chance, if you don't have column names, or for some reason you want to skip them in the file that you are actually reading in, then you have to specify column names, so call underscore names equal to false. But we are happy with this solution here. So we run it and we actually read it into R with the 10 columns with the characters and then 10 or 6 columns with a double. So this is a number in these columns. So if we click on this, so basically what we have is the data already in R in the format that we are used to. The other part of the video I want to talk about briefly is about writing out the R data sets onto your computer. So you want to do this one also from time to time, or well, depending on, of course, what you do. Here, there are also many possibilities. The same way, if you start to type right here, so you have all the options. Again, with the dot is generally from base R, and with the underscore, these ones are from tidyverse. So for this particular example, we take the data set we loaded in. So this is the all frogs. And for example, we keep only the rows that have their habitat type in a pond. We can do this with the filter option as we described it in one of the previous videos. And then the next thing that we want to do is we want to write it out. And again, my personal favorite is the write underscore delim, because I can specify whatever delimiter I want. And my personal favorite for the delimiters is the semicolon, because it is one of the, in my opinion, one of the nicest signs that you could use for distinguishing columns. Now, very often, well, the space is used, but it's well, it has its own problems, in particular for the missing records. So in that case, there are multiple spaces after each other. Well, you can use comma, but depending on where you come from, so which country you come from, commas are sometimes used for, well, instead of a decimal point. So we don't have many times decimal point, but a decimal comma. So that might be confusing. Semicolon is not used that often. So that's why I love to use it for the delimitation of the columns when I am writing out any kind of file. So if there is nothing specific required, my go-to sign is the semicolon. So the write delim itself is also very easy to use. So basically you specify the file name that you want. And then in case you use the write delim, you also need to specify the delimiter. Again, if you check the help file, so there are a bunch of things that are considered by default. So, and also then later on described in more detail. So if you are not happy with any of these, you need to change them. There are below here the descriptions, actually what they mean, so you can read up on them. So we have these frogs here, we filtered, we are happy with it, and we want to write it out, and it can be done with a one simple click. And indeed, in this new file, there are only the frogs with the habitat type, which are in a pond, and the columns now are separated by semicolons as we specified. So again, the two very useful and very frequently used options are of reading in and writing out files from and to your hard disk. Definitely a very good idea to know about them in greater detail. So this was kind of a closure in this playlist of the most important and most frequently used R commands. Of course, in terms of importance and frequency of usage, this is a very subjective thing. So if you remember in the very first video, I told that, well, these are the R commands or functions that I use very frequently in my R scripts. So, well, I just felt it is useful also to you to know about them. So definitely check out the videos on this playlist, especially if you are a newcomer to R. By knowing these commands or these functions, you can do a large majority of the stuff, especially when it comes to work with genotype data in terms of data preparation or adjustment for analysis, for example, for Blink. Also, if you have your own favorites, of course, be sure to put them down in the comments below. Which R functions are the ones that you find particularly useful? From my side, I thank you for your time for this video and for this entire playlist, and I wish you a very nice day.